Hi, and welcome to the Time Value of Money Spreadsheet Help Review. This is the first tab called Future Value, and we're calculating the future value of 10 various problems. So the first problem is calculating the future value of a lump sum of $100. And you notice that $100 there's a negative sign before it because this is what we call present value. So this lump sum is actually the present value. Okay. And then we have 3 years, and this 3 years would be what we would call N per in Excel, or the number of periods, because this is an annual. Unless otherwise expressed, assume all problems are annual, and it actually says here annual rate, so this would be, of course, the rate. Now we want to calculate the future value, meaning what is this $100 going to be worth in 3 years at a 10% rate of return each year. So we can go to Insert Function. We can look under the Financial tab till we find future value. You could also search for the function by typing in FV and searching for the function. And then here we have FV. Okay, so rate is the rate, N per is the N per, and present value is the present value. And this will calculate for us the future value is $133.10. I'm going to insert a comment here. Use the future value function in the just a little comment there. And what's nice is, once you have this calculated, you could easily copy it to the next problem and the next problem. So these problems are all similar problems. We're calculating a future value of single sum. Now here, if you ever get these multiple hashtags, what you want to do is come into the home key, and you want to reduce the size of the lettering here. So we could hit the smaller button here, or we could just, click it to size 11 font. You can also resize the cell. If you get these hashtags, you can double click up here to resize the cell to make it big enough to fit the box. Okay, so let me just shrink that. Okay. And you can just also pull it if you want to just change the size of this one column. Okay, so let me just do this one more time for problem 4. You want to go to Formulas, Financial, Future Value, and you want to put in the rate, the N per, and the present value. And once again, the present value for Excel, they always want the present value to be expressed as a negative when you're calculating problems using their financial functions. Okay, so now let's move to problem 5. So in problem 5, we have a calculated future value of a $1,200 lump sum for 4 years with a 12% annual rate, but compounded semi-annually. So at the bottom of this file, I have a little schedule here where we have the term annual, semi, quarterly, monthly, daily, and a frequency denoted by the character M. So frequency would be 1, 2, 4, 12, and 365. And this just means the compounding occurs multiple times in 1 year. So for, again, the lump sum would be, this is our present value. The 4 years, this is not our N per, this is just our years. So to calculate the compounded frequency, this would mean that compound semi-annually, this is really our frequency, or M denotation. And for semi-annual, if I look at this little chart down here, semi is 2, so I'm going to make our frequency 2 here. Okay. But not 2%. This is going to be just a regular number. So I'm going to change this to number, I'm going to retype that as 2. Okay, so now when we calculate our future value here, go back to formulas. I'm still going to use the future value box. So the rate is going to be the annual rate, but I'm going to divide by the compounding frequency. N per is going to be the years, but that's going to be multiplied by the frequency. And the payment, we don't have a payment here, but we do have a present value. And we're going to hit OK. Now, I divided by the compounding rate, the frequency, because the 12% annual rate is really going to be applied to 6% every 6 months. And the 4 years, the N per is the frequency of compounding. So if it's semi-annually, we're compounding twice a year. So 4 times 2 means there are 8 compounding frequencies, or the N per would be 8. Okay, so let's go through that one more time. Here again, the compounding rate is 2. If it was quarterly, it would be 4. If it was monthly, it would be 12. So it's just the frequency of compounding within a year. So again, when I want to insert the function, the rate will have to be divided by the frequency, and the N per would be the years multiplied by the frequency. And the present value is 12. So we just hit OK here. Now, if this said quarterly, if it was compounded quarterly, I would do 4. And you see how it goes from 1642 to 1647? And if I do it, say it was monthly, and I would go to 12, 1650, and it was yearly, daily, 365, you see how it goes to 1652. So what we learned there is as you increase the frequency of compounding, you increase the amount of return you're going to get, because you're earning interest on your interest. Okay, so let's move down here to, we're going to work on something different. This is lump sum, and now this is an annuity payment. So annuity payment, what we're going to do here is we're going to change this. This is now going to be, it's no longer a present value, it's PMT for payment. This is going to be, since we're calculating this at an annual rate, this would be N per, and of course this would be rate. So calculate the future value of an annuity, $250 annuity payment for 5 years at 10%. So annuity payment, a payment is something that reoccurs. So there's going to be a $250 payment every year for 5 years, and it's going to grow. So think of investing $250 a year every year for 5 years, and you're earning interest on that money. So it's going to grow to an amount much larger than $250. So if we're going to calculate the future value of annuity, again, we're going to insert the future value function here, and now the rate is going to be the rate, N per, since annual is going to be the years, but now we use this payment field. So this is going to be the payment field rather than present value. So there's no present value, this is the payment field. And for type, since this is annuity, this is going to be ordinary annuity, so the payment's going to be made at the end of the period or 0. So we can put 0 here or leave it blank. Either way, I'm going to leave it blank. You could enter 0. We'll get to where you would use 1 in the next 2 tabs down. So let me just say OK. So this will calculate. So this makes sense? Yeah. What is $250 a year times 5 years? It's $1,250. So this seems like a legitimate answer, including the interest. So here's how you calculate what a payment you make for 5 years, what that would grow to as far as the future value of that. Okay, so I'm just going to take this formula and paste it there. Now let's move to annual deposits to accumulate to a future sum. So here we have, these are our annual. This is our future value is going to be $4,000. Okay, so they're giving us our future value already. And we want to know what deposits would we make to accumulate to this future sum. So this means, this is basically saying payment. So we're calculating payment here. So this would be, in this case, because it's annual, this would be our N per, and our rate is our rate. And there's even a little message here saying use the payment function in Excel. So again, I'm going to search for payment, but I don't, search for payment. So I could use the PMT function, and in the PMT, what I'm solving for is PMT. So my rate is the rate, N per is annual, so it's the years, and we have our future value is here, and it even says C, annuity future value, FV. So I have my three inputs, and I'm going to hit OK. And this is expressed as a negative number because it's a present value, it's a payment. So payments, although this is how Excel expresses it, most problems would be, we would show this as a positive number. But for Excel, they express payments as a negative number because it's in the present value family. Okay, I'm just going to post this over here. Oops, a little too far. I'm going to put it in this cell. So I can just easily copy it over here. And if it was $25,000 for 4 years at 5%, annual payment would be $5,800. Here are the actual future value formulas if you want to calculate it using the variables from the textbook. Okay, so that's the future value page. Let's move to the present value page. Okay, so now we're going to do time value, present value, and I want to increase this screen size here so it's more viewable. There we go. So the first one, we're calculating the present value of 100. What is $100? If I'm going to receive $100 3 years from now in the future at a 10% annual rate, what is that value worth? So our first value here, the $100 is a future value. This here, the years, this is our N per, and the rate is the rate. So see, it says present value equals, so of course I'll put a little comment here. Use the present value Excel function. Found on the formulas menu. Okay, so that's a little hint there. Okay, so now we're going to open this up. I'm going to search for present value. So here, our rate is the rate, our N per is the years because it's annual compounding, and our future value is $100. So this means that in today's dollars, you can see how present value is, it's always expressed as a negative, but oftentimes on a test or maybe a homework manager, when they ask for present value, they're going to want to see it expressed as a positive number. It's only really Excel that puts present value in negative terms because they think of it as sort of a payment. So that would be our present value. Okay, so I could easily just, this is the nice thing about Excel, once I have the formula, I can apply it to the other cells and it'll recalculate as long as the cells are in the same layout. It will move the formula and copy it for me. Okay, so that would be the first 4 problems or similar problems calculating present values. And now we have, what about if there's the compounding frequency is going to be semi-annual? So we know that that means 2. And let me change this to a number. So this is going to be 2, and that means that what we're really seeing here is this is m, the frequency. And this is going to be the same for both problems. And of course we have our future value here, so I'll just label this is not N per, this is just years, so not equal to N per, and this is our annual rate, which is not actually our rate. which is the annual rate, but we need to find the semi-annual rate and the semi-annual NPER. So when we calculate this, again, we're going to use the future value. So we can use the future value here. And so our rate is going to be the annual rate divided by 2 to get our semi-annual rate, and NPER is going to be our years multiplied by 2 to get our semi-annual NPER. Because NPER is not number of years, NPER is the frequency of compounding, and we have 8 compounding opportunities in semi-annual compounding for 4 years. Okay. Now we also have our future value. So if we calculate this, this would be the present value. So if I'm going to receive $1,200 in 4 years at a 12% annual rate, compounded semi-annually, that's only the present value of that is only $752 today. So let me just move this, copy and paste this formula over here, because these problems are identical, except the annual rate here is less. So we go from 12 to 8%, and we see that the discounting is lower. So the lower the annual rate, the less the discounting. So at a 1% rate, you see that it's, if we do a 0%, that means there's no discounting. So when you're changing the discount rate, the higher the discount rate goes, the lower the actual present value is, because it's the percentage of discounting. Okay, so let's move on to annuity. So here we have calculate the present value of a $1,200 annuity payment for 3 years at 10%. So if someone's going to pay you $1,200 a year for 3 years, what's that worth in today's terms? Well, $1,200 times 3 is $3,600, but that's not what it's worth today, because you're getting some of this money in the future and it's going to be discounted at a 10% level. So what this is annuity payment is basically the payment term. And so we're going to use, I'm going to put a little note here. Actually, I don't think we need a note. I'm just going to go back. We're going to use the present value function again. And we have our rate, we have our NPER, and we have, this time we have a payment. Okay, so this $3,600 is really only worth $2,900 today because of this discounting. So let me put that over here. These are identical problems. Okay, so let's go to annual payment amount to repay a loan. So we borrow $6,000. So if I'm borrowing $6,000, that's actually, you can kind of think of that as a present value. So I'm getting that when you make this, when I borrow this money, I'm getting this money today, right now. So that's a present value. So I'm going to make that a negative. And I'm going to, so if I borrow, I'm going to actually label this present value for 4 years. So this is our NPER, and the annual rate is the rate. So here, we want to use the payment function in Excel. Another little hint here. So I'm going to insert the function, payment, and I have my rate, my NPER, and then my present value, because this is the present. You borrow the money, you get all the money today. The present value is $6,000. But what is going to be the payment I'd have to make each year to pay that back? And the answer would be $1,975. So, so $1,975 times 4 years, if you actually look at how much you're actually paying back, you're actually going to pay back about close to $8,000 for the $6,000 you borrowed because of the added interest. Okay. So I'm going to just copy this field, post it over here. So if it's 3 years you're paying back, your payment's going to be higher because you have 3 years to pay it, not 4. And these are the actual time value money formulas for present value, and our frequency table added in again. Okay. So let's move over to Annuity Due. This is our type 1. So Annuity Due, so these problems are annuity problems. So you only worry about Annuity Due and ordinary annuity on annuity problems. This isn't really something you apply to lump sum or single sum problems. So in the first problem, calculate the future value of this annuity payment. So we see annuity payment, we should know right away that this is a payment value. Okay. Now we want to calculate the future value of annuity, so I'll just leave a comment. Use future value function. Okay. So let's go and open up future value, and I have my rate, N per, and payment. Now the type is, here's where we use the type. This is annuity due problems, so I'm going to put this as 1 because they're annuity due, and that would be my answer. That would be the present value, a future value of these. So 5 years of making this annuity payment at a 10% rate of return would equal 1678, would be my future value of annuity. Now these are all annuity due problems, which means the payment comes in the beginning of the year, not the end of the year, so we get an extra year compounding, and that's what this type 1 stands for. Just think of it as extra 1 year of compounding. Now let's try that again. Here's another calculating future value of another annuity payment. I could copy the cell down, but I'm just going to recalculate it. So again, the future value, and I want to put in the rate, N per, and then the payment. And this would be my future value, but this is not actually the correct answer because I have to remember to put in 1 as the type. So let me just cancel this. So you see how this is 7675, and you'll see this number go up because when I put in the 1 to denote that it's annuity due, this will actually increase the value to 8,000 because there's extra year of compounding. Okay, and the fifth problem again is just calculating. It's the same problem as before, so you use the same procedures. I can just copy this down here. Okay, because this is 15 years, so we see that this grows to be a much larger amount. Now, let's switch over to the second column. We're looking for present value, annuity due present value problems. So you guessed it, we're going to use the present value function, and we have our rate, our N per, and we have our payment, and this will calculate the present value. So we know that 3 years at $300 payments a year is $900. But since we're present value means that we're always shrinking the value of the results. So it's not 900, it's 800 that we see once we discount for the present value. I'll just make this to note that that's a payment. Okay. And that would be, this formula can be used on both of these. And we see that 15 annual payments of $567 and a 13% discount rate is only going to calculate a present value of $3,644, which is, if we looked at what is, 567 times 15, if there was times 15 years, we see that's 8,500. So if we said this was 0 rate, we get that 8,500 here. But since we're discounting at a heavy 13%, it takes, almost $5,000 of that money away just for discounting. Okay, so these would be types of annuity problems where, oh, I should check. Did I put in the, I did because I copied it. Let me just pull up the box. It's gonna, oh, nope, it's not there. So here, let me start up here. I got to put in the 1 to note annuity due. And you see how this is actually going to increase the value because there's 1 more year of interest that will be applied. Okay. So when you're calculating these problems, you have to remember to put in that type 1 to denote annuity due. Okay, so let's move on to the next sheet, which is solving for R. Okay, so we have two other different types of problems. What if we're solving for R? And R is, what we're solving for is the rate. So let me just put in rate here, and I'll just put in R. I think it's a little bit more descriptive of what we're solving for. And it seems to want to turn it into another symbol. Okay, so we're solving for R. So let me just update these cells here. What we're really solving is for rate. So here I have used Excel rate, the Excel formula to solve in Excel. So use the formula rate. So let's go to formulas, and we can search for rate. And we get our dialog box. So N per would be the years. Now let me just put this in here. N per, it's going to be the rates, and this is, so the present value, remember, for this to work right in Excel, I need to express this as a negative. So I'm just going to update these and put these as negatives so that in the formula these will come out, the solutions will come out looking like a whole number. The percentage will be correct, otherwise they won't be able to calculate. Okay, so now we're ready. Let's put in let's use the rate formula. Okay, so we have, these are all annual problems. Like I said, we're going to assume annual unless it specifically says semi or quarterly. So any problem where they have just the years, they don't express what the compounding frequency is, we assume it's going to be annual. So we could use that as our N per, our present value, and we also have our future value. So if we have as long as you have three conditions, we can calculate the fourth. So it's just simple algebra. So I have the future value, present value, and the N per. This will be able to calculate the rate for me. So the rate here would be 7.2. So let's do that one more time over here. Use the rate function, N per, present value, future value. Okay, and we get our rate. And then I could just, I could copy this formula. Instead of reusing the function box, I can just copy this formula around to get my rates of return. So that's solving for rate. Now let's go down here. What if we're solving for N per? So what we want to find here is, what is N per? So let me put that here. Just shrink that a little bit so it fits in the box. So I think that's a better description. So we know, because years is not the same as N per. It just depends on the frequency. When compounding is annual, N per and years will be the same. All these are annual compounding. But if the compounding frequency was different, N per would be different. So we're solving for N per. So we're looking for the number of years of investment. Okay. So here's a nice note to use N per to solve in Excel. So if I go to formulas and I'm going to search for N per, and I have my rate, present value, and future value. So I have these three. I'll be able to calculate the number of years here. So let me format this down to 2 decimal places. And we'll do that one more time. Our rate, present value, future value, and we can know what the amount of years it will take to save for this investment. We'll see here that if, let me hide the comments. Okay, so we see that if we have a loan, if we're solving for a loan, this actually, this is a little bit different. So this is not the, let's do this. If we're solving for a loan, this is solving for an investment. Here, we're doing a loan. So what we have is we have the rate, and then we have the payment. This would be the payment. And then we have the present value. Let's see if this works. Okay, it does work. So this would be N per would be 8.15 years. So if you had a $25,000 loan making a payment of $4,800 per year at a rate of 11%, how many years do you pay off the loan? 8.15. So let's do the same thing over here. Our rate, payment, and present value. 10.87. And in this case, since the payment is considered the present value, only one of we can't have both of these negative, otherwise it would cancel each other out. So we just keep the payment as a negative here to get our N per or year's result. Okay, so let's now move to the mixed stream. Okay, so this is the mixed stream of what if, so if these are annuities that don't have even cash flows. So we have different cash flows for each year, not the same amount every year. So annuity is a cash flow of equal size. These are different cash flows. So how do we calculate the present value of a mixed stream of cash flows? We could calculate each of them individually using just the present value formula. So if we wanted to calculate each of these individually, we would have to go in and we click on present value, and we would have to go, put in the rate. N per would be the years, and then we would put in the future value. This would be the future value for one, and then we could calculate the present value for each of the cash flows. And that we'd have to do each one of these individually, open up that dialog box. We can't just copy it straight down and set those up. So that would take some time. If we just want to get the total present value, we could use this net present value function, which is another nifty function. So NPV, net present value, we're going to search for that. Here we got net present value. So here we put in the rate, and then we put in each of the values for every year. So year 1, value 2 would be year 2, value 3 would be year 3, value 4 would be year 4, and I'm just going to, there's a little scroll box down here, I'm just going to scroll to get value 5, and then hit OK. And this calculates the total present value. So these cash flows together are over 144,000. But the discounted cash flow, the total present value, is only 56,000, discounting at 8%. Oh, I'm sorry, the total cash is 72. So if we add up these 5 values, this is a sum. So the total cash here is 72,000. But the discounting it for 5 years at 8% brings it down to 56,000, or the net, what we call the net present value. What about if we wanted to find the total future value? So here I left a little message saying, let me edit this comment to make it a little bit bigger. There we go. Okay. So in this comment, you can use the future value function in Excel, use the net present value answer as your present value times -1. Okay, so what we're going to do here is we're going to calculate the future value. So we're going to use our future value function, and we have the rate of 8%. We have the N per of 5, and we're going to use this as our present value. So we're going to actually put in this as our present value, and I'm going to say multiply by -1 so we don't get a negative answer, and we hit OK. And this would be our total future value. What happens if we don't put that -1 in? So let me take out that -1 here, and we just set the present value as a positive number. You see that it's going to make this, just going to make it negative, and the future value should not be negative. So we're going to say times -1. just to make that a positive statement. And that's how you could calculate the present value of a mixed stream and the future value of a mixed stream. Okay, so let's move on to the last worksheet, which is effective annual rate. So a nominal rate is just the stated rate of interest for the year. So let's put this as like that. And use this format painter and just paint these down here, keep them as percentages. So the nominal rate is just going to be the express rate. But the effective annual rate is what is the rate really if we change the frequency of compounding. So if we change the frequency of compounding, the rate, the effective annual rate goes up because we have more opportunities for compounding. So to calculate this, we could use what's called the effect formula. So if there's only one annual rate and the frequency m is 1, there's going to be no change in the nominal rate expressed by r and the effective rate. So I should put this here because this is what we're calculating. Oops. All right. And let me just center that so it looks good. So this is what we're calculating is the effective annual rate. So to do this, I'm going to go back to our formulas tab and then insert and look for effect. And here's see there's also nominal too, but we're calculating the effective rate. So what we need is the nominal rate and then what they call the m per y, which is the frequency. It's really a frequency. And I'm going to say OK. So actually let me just put over here n per y. That way it'll be easier for students when they look at this to know what they're entering in Excel. Okay. So again, let's do this one more time. I'm going to insert the effect function. It's looking for nominal rate. So this is the nominal rate and the m per y. And this is 4. Oh, actually, we want this to be 4. They should be here. And we get our, and you see how it goes up. Each year it's going up a little bit because when you're increasing the compounding, you're going to be increasing the effective annual rate when you increase the frequency of compounding. So here, let me just relabel this nominal so you know when you're entering in the cells. Okay. And I leave the bottom part for you to do down here. Oops. The bottom section here for you to do. And remember, when I'm grading these, I'm looking to see that you have the formulas in the cells. So don't just copy off of here and type in the numbers. I have a number of students do that. I don't know why. Okay, so this ends our time value of money Excel spreadsheet help video, and I hope you find this helpful for solving these problems. Okay, thank you and take care.